This video is to help you calculate rates. It assumes that you know how to find a factor in an exponential function. If you do not, please watch the video on how to find a factor of an exponential function. So let's start with some basic factors. Let's say you have a factor of 1.23. To calculate the rate, it's very simple. I subtract 1 from my factor. Well, 1.23 minus 1, I can do that in my head, is 0.23. This is called the little r, I should put a big R over here, for the rate, because it's in decimal form. As a percentage, it's the same number. Again, if this was in dollars, this would be $0.23, but we generally would not describe it as having $0.23. What we would normally describe as having 23 cents. Decimal, cents. Dollar and decimal, percent, cent. Same thing you do with money. So $0.23 is 23 cents. 0.23 in decimal is 23%. Okay, so let's take some other factors real quick. So let's say you have 1.0625. Subtract 1, easy peasy, 625. That's in decimal. Multiply by 100, move the decimal place over twice, 6.25. So if I have a factor of 1.0625, that's how much bigger it is than 1. I just subtracted 1 from it. Multiply it by 100. Let's look at some other interesting factors. 2.321. Find the little r, subtract 1. To find big R, multiply by 100. So if you have a factor of 2.321, you have a little rate in decimal form of 1.321, or in percent form, you have a growth rate of 132.1%. Now let's talk about factors that are smaller than 1. These get students in the most trouble. It all depends on how you are asked to give the information. For instance, 0.98. Let's make that 0.98. So we see the lead 0. I subtract 1 from this value. I get lead 0. 0.02. Negative. That's key. As a percent, negative 2%. Very important. It is perfectly okay to describe a rate either in decimal or in percent form as negative, unless you've already stated that this is a decay rate. What do I mean? Same question, but I ask you to tell me that it's a decay function. And you have a rate of 0.98 is your factor. Yes, when I subtract 1 I get a negative, but when I use the word decay means negative. So if you remember, decay means negative on a rate, it would be redundant to say it. So a negative decay rate is a growth rate. Do not use both the word decay and the sign negative. That is wrong. It's unacceptable and you'll lose points on it. So as a decay rate, it is 0.02. My math is the same. I subtracted 1, but the word decay means negative, so it's already there. As a decay rate, as a percentage, it's 2% decay rate. So again, it's very important whether you're displaying it as a decay rate or simply asked for the rate. If I simply ask you the rate, it's negative 0.02. If you're first asked to describe whether it's growth or decay, then it's decay rate of 2%. Let's look at some other ones. 0.027. If you subtract 1 and you're asked to first describe it as growth or decay, this is a decay function. function because my factor is smaller than 1. So I know I'm going to get a negative number, but I'm not going to display it as negative number because the word decay means negative. So, when I subtract 1 from this, you're going to get a negative, already accounted for in the word decay, 0.083. You can verify that, 73. Verify that with your calculator. And move the decimal place, I did that completely wrong, sorry. Start over on that. 0.973. That is my decay rate. This is not the factor. This is the factor. This is the rate. As a percentage, this rate is a decay rate of 97.3% decay rate. So hopefully this helps you a little bit with identifying rates. That's a big aspect on the final exam.